using Ansible to just set up and establish different environments in AWS Cloud. So I'm going to go ahead and record as it's all right. Okay, it is going. Okay, good. Yeah. So with this recording, this will be available afterwards. I have a YouTube channel where you can go back and have access to not just this session, but any of the past meetup sessions that we've had, just to kind of gauge where everybody is. So, so those of you today, how many of you are new to AWS networking? Could you give me a thumbs up? Okay, and it looks like I have a question that came in. You could just unmute yourself if you'd like to ask the question, or you could use the chat if you want to. And the chat's like in the bottom right hand corner. Okay, so or maybe you're raising your hand because of the new to AWS thing. Yeah, so if you want to use the emojis, I guess it depends on if you're on Windows or Mac or on Linux. They may be located in different spots on Google Meets. The ones that I have are like in the middle of bottom, the middle of the bottom of the screen. So you should have them somewhere in your environment to be able to use those too. But if you raise your hand, then I'm assuming that you have a question. So just to distinguish between the two. So, so on the other side of this, how many of you are new to Ansible automation? If you could do a thumbs up. Okay. Well, if you're either new to AWS networking or new to Ansible networking, you'll definitely get something from this session. And again, this session is kind of like a starting point, and I plan on having additional sessions to complement this one. So over time, we'll build layers of learning on top of this. So for this particular topic, you can kind of think of it as a series. This being the intro to AWS networking in February 22nd, I've scheduled like the next step. So today, kind of think of it as we're learning to count from 1 to 10. And then in February, we'll learn to count from 10 to 20, right? So it doesn't make any sense to start, from an intermediate level. So we have to establish, a baseline of knowledge around AWS networking and also around Ansible too. So again, the focus is more around the AWS side and not so much like everything that you would need to get up and running in Ansible, but it will, give you some insights into how it would look. And I'll provide some links. Excuse me. I'll provide some links that are very useful for those that are interested and new to Ansible. Like, how do you get started with Ansible, and more specifically with Ansible network automation in general, where you could apply it to your on-premise, routers and switches, as well as cloud, right? So this is just another networking topic. It just happens to be AWS cloud. So let's go ahead and get started. And again, if you don't have any questions, you can always follow up with me afterwards. So if you think of something after this session, feel free to put a comment like on the YouTube channel, or you can access the meetup group and you can go back to past events and you can leave comments there. And another aspect of that meetup site is I'll add links to a past event. So I'll give you like a link to the slide deck. If there's any additional like GitHub repositories or any other artifacts from a particular meetup, then you can go back to that site and I'll add links to those afterwards. So if you join here from Meetup, you can just go back to the Ansible for networking, and then you'll find what looks like today it's an event, but what it'll eventually become a past event like after tomorrow, right? And then you can go back and still have access to any of that content that I put in there, or if you want to leave a comment. So without further ado, let's go ahead and get started. So one of the things that we're going to look at, and again, this is just kind of front ending the conversation with where to go. If you are interested after this session in using Ansible to configure your AWS networking environment, then you're going to need to have access to the AWS modules. And there's two different ways that you can have access to them. Both of these options involve a collection. So I don't want to go too deep into the Ansible side, but one thing that you do need to understand is that any of the automation that you're using, or that you're um, utilizing Ansible for, you'll have to have access to the correct modules, and those modules are constructed, or they're compiled into what we call a collection. So a collection is just a vendor in our ecosystem that works with us, or it could be an individual contributor, and they make modules available in collections. So with a collection, you'll need to install that into your environment. What we're talking about today is the Ansible Automation platform. So, having said that, what I'm using is what we call execution environments. So, with an execution environment, I do in fact need to have one that has the available modules that I need to use for my playbooks. So, for today, and what I had to do, and what you'll need to do if you haven't done so already, is if you go to our community site, which is Galaxy, then you can pull down the collection of the AWS modules. And from a naming perspective, we have a dotted notation around what we call a fully qualified collection name. So this would be the Amazon.aws, right? So you can pull that down from Galaxy. And again, I'll make this slide deck available, so these links will be available for you. So you don't really need to do screenshots and all that stuff unless you want to. And then if you're a customer of Red Hat, and you have the Ansible Automation platform, then what we recommend doing is going to what we call the Automation Hub. And the Automation Hub is located on the console, which is like a centralized site where Red Hat customers go, not just for Ansible content and other software, but it's for all of the Red Hat software. And once you access the console, then you have access, in this case, in this link, to the Automation Hub. And then that's another location where you can have access to the collections. The only difference here is that as a subscribed customer, then you can open up tickets with Red Hat if you have issues with a particular module, as opposed to Galaxy, where that is the community site. And in order to have help there, you need to go to like specific GitHub repositories and log issues. So that's kind of the main difference between those two. But we'll kind of table this. We'll circle back to the Ansible side of things, but I just wanted to call this out, that this is what you're going to see running under the hood, if you will, as I go into my demonstration to show you how these things work with a live demo. So now back to the AWS side of things, right? So with AWS, there's a lot of networking constructs that are, very different than what you would expect to find like in just traditional networking. So for those of you who are familiar with networking and have spent a significant amount of time building networks on premise, and perhaps have your CCNAs or CCNPs or CCIEs, a lot of those constructs are different in AWS. And in some ways, there's things in networking that you would expect to see are not available in AWS, just because for the most part, it's a cloud, it's virtualized, there's abstractions, and things like layer 2 Ethernet don't exist, or at least they don't exist in the networking that you have access to as a consumer of the AWS public cloud, right? So some of those, infrastructure in terms of the way that we think of it as a network engineer do exist, but it's not something that we access directly. So the constructs that we're dealing with are all virtualized. So you can kind of think of it sort of as the cloud being sort of the like virtualized overlay, that you have APIs, programmable APIs, to make configuration changes and to add, new components up into your environment. And we're working at that layer. So from a consumption standpoint, you may be using, your AWS console to build a lot of these constructs, but under the hood, there's routers and switches and firewalls and things. It's just that you don't have access to those directly. So you can kind of think of like a virtual private cloud is really that foundational component that brings everything together from a networking standpoint in AWS. So a VPC, it includes other components that we're going to talk about, and we'll unpack these kind of one by one in these slides before we get into the demonstration. And some of these things are additional abstractions, and some of them are similar to what we're used to in traditional networking. So one of the things that we deal with in a VPC is that we will create what we call a CIDR block, right? So we need to have a network space to get started with and assign to that VPC. So normally a CIDR block is created from an RFC 1918 range. So like you can use a 10 dot space. It's kind of like the default in there. And there's 172 addresses, and all these private addresses that align in that in that paradigm. But you could use public IP addresses too. But you just have to be careful because what we're talking about today, again, because this is like the intro into AWS networking, is we're working in a single environment, and we'll talk about other aspects of that, like the region and availability zones, and everything that we're doing is kind of it's meant only to run in this single environment. We will use two availability zones, but those are bound to like a single region. So in this VPC, we don't have a lot to worry about in terms of like overlapping addresses and things like that. So those are the things that you'll have to take in consideration, because as we move forward in our discussions, we're going to start talking about how can we connect multiple VPCs, so multiple regions together, how can we peer them, and also how can we internetwork with our on-prem environments and also have them peer with the VPCs in our AWS cloud environments. So when we do that, we kind of have to think from the beginning when we plan our IP addressing and things of that nature. What do we need to connect to? Because ultimately, that will culminate into environments where we may have overlapping IP addresses. We may need to use additional NAT techniques and things of that nature, just depending on how things are set up. So we just want to keep that in mind. And that's kind of why like AWS, they kind of get you started with their defaults in moving down the road of kind of like that safer way of getting started, especially in like their default environment. So there is a notion of like a default VPC, and that's what you have when you first establish your tenant environment in AWS. But normally that's only used in the beginning, and what you should be doing is creating your own net new VPCs as you move forward. So as you do that, subnets align to these CIDR blocks, and we'll start to create in these subnets. We'll use our subnet mask, right? So we're going to have the main CIDR block, and then we're going to create subnets from that will assign to our VPC, right? So we can have multiple subnets, and those subnets could either be on public or private networks. And we'll kind of table that because we're going to get into that in more detail. But in this particular example here, it just shows subnets, but those could be public or private. And then we'll distinguish what that means as we go into subsequent slides. So once we have our subnets, the other thing that we have to take into account is the default settings for things like network access control list. So by default, the network access control list, and I have a slide that we'll talk in more detail there as well, but just at a high level, those allow everything by default. So it's kind of like when you're working in like a traditional network, the default, unless you apply an access list to an interface, you have interfaces that allow all traffic. And that's sort of the same here, because behind the scenes there is a router, and that's where those network access lists are applied. But you don't have the ability to connect to that router directly, but you do have the ability to create these access control lists for your subnets that are using the AWS routers. And we'll see that in a diagram, so that'll make a little bit more sense. So other things to take into account in a VPC are the gateways that we might need. So one of the gateways that we typically always have is an internet gateway. So without an internet gateway, there's no way out of the VPC. So even if you create a public subnet, until you have an internet gateway, you have no way to have inbound and outbound traffic, from the actual internet. So that's one type of gateway. There's another type of gateway that we'll talk about, and that's a NAT gateway. So that one's a little bit different because it's meant for devices that are on private subnets that have no inbound connectivity to them. And you're just establishing a NAT connection, or what we call like a source NAT, a SNAT, where you have outbound connectivity. So that way you can establish connections. So let's say you have a database server that you don't allow access directly from the internet. That database server would still need to be updated, right? So if you want to provide access from that server to the internet for updates and things like that, you can do that. So it's sort of like your home internet, right? So by default, your home router, it allows you out through NAT, and you can connect to anything unless you start to build rule sets in that router. But nothing by default has access to your internal network until you start doing like port address translations and opening up ports, that type of thing, right? So that's kind of like what a NAT gateway is, but it's not intended to ever allow inbound traffic. So those are sort of just the main components, sort of the canvas that we have where we can start setting configurations and establishing what we want to see and how we want the VPC to work, right? So the VPC is kind of like the wrapper around all of the networking. So you can see that here, and it can span across multiple availability zones. And an availability zone in AWS, if you're not familiar, is really like you could think of it as a separate data center. They might be in the same, they're within the same region. They might be in the same location. They might be like in the same metropolitan area, closely located to each other. But it's, within a region, and it's close enough to where they, establish, high bandwidth connectivity and availability, between them. So it's as if you're on a local area network. So those all, work within the confines of the VPC. So here's the internet gateway, and we'll go through some of the rules of what you can do with that in terms of configuration. So here's the internet gateway, and you can see that it can connect. Also, you can have the multiple availability zones. In this case, there's a public and a private network. And if you were to, spin up instances in either one of these, then they would be able to have outbound connectivity to the internet. But the public one would be able to have inbound connectivity, but the private one would be using just that internet gateway. But you could establish inbound if you wanted to these. So it's a little bit different than in the SNAT configuration. Then you only can have the outbound. So that's actually what we have on the next slide. So this one doesn't have a diagram, but it's what I'm referring to with only giving you really the outbound capability. So that's the biggest difference between an internet gateway and a NAT gateway. Is internet gateway can be bidirectional, and then the NAT gateway only allows access from inside to outside. And whatever you establish as a connection, you have bidirectional traffic, but you couldn't like have a web server, if that makes sense. Now here's subnets. So with the subnets, they can only be associated to one network access control list and one route table. So we'll talk about route tables, right? Because route tables are the same thing, whether we're talking about routers, physical routers, or talking about AWS. So this route table in AWS establishes a target for like the outbound or the next hop. And when we have a NACL, then that is bound to this like AWS route table for that subnet. And the thing about like the access control list is that they're not stateful. So you would have to provide like a permit because it's going to read it, in ascending order. So that way, if I permit, certain address space that I'm allowed outbound, and then once I hit a point where it becomes like a default, deny everything else, right? So like it's implicitly denying. So we permit, then deny. So we have to do that outbound in addition to inbound. So with a security group, we're going to see that that's stateful. So the difference there is like if you're familiar with like access lists from, again, like back to routers, um, there's like a notion of like reflexive access lists, right? So that one, if you make a connection, then it'll create in the access list, it will allow for the inbound. But with this type of network access control list that is connected to a subnet, you have to explicitly say the outbound and the inbound. So if you leave it alone, the network access control lists allow all traffic. But as soon as you start to explicitly permit in one direction, then you'll have to permit in the other direction as well. So those become a bit more complicated. So what you'll see is in practice, a lot of times we'll use security groups instead because they might be a bit easier, but it just depends on what the intent is, because the security groups have to be applied to like every one of your endpoints. And then access control list here, as you can see, like that controls that entire subnet that would have multiple endpoints connected to it. So with the subnet, again, we have to have an association into the route table. So that way, if we're just doing like a default gateway, it's pretty easy because in the route table for that subnet, the route target would just be that internet gateway. But if we start having like multiple things in this environment, like an internet gateway and a NAT gateway, or in other things like we're not going to talk about today, like VPN gateways and things like that, or if we actually implement like a virtualized router in our VPC, then that becomes another route target. So all of those need static entries depending on the subnet, right? So if we have like a network prefix that we're trying to access and the next hop is like the virtual Cisco router versus the internet gateway, we can do all those things, but we have to start populating our route table. So that is not introduction to AWS networking. So we won't be doing those things into the next session or maybe even the one after that, right? So that's where things start to become more complicated because as any route table, as we're using static routes, it becomes exponentially more difficult to manage that. And a lot of times depending on what the use case is, we might start implementing like dynamic routing, like BGP as an example, depending on what we're talking about and what we're peering with. But in this case, everything's just a default gateway, and that's how we have it set up today. So here's the route table, and just to give you like a visual of what I mentioned on the previous slide. In this case, we have a default route, and the target is this internet gateway, and whatever the internet gateway's ID is. So when you create one of these for a VPC, then AWS will assign an ID. So each one of your targets has its own ID. So if you have more than one internet gateway or some other type of gateway, they all have their IDs. But in this case, like we would only have the one entry. If we only have one internet gateway in our VPC, and then we use it as a default gateway, then we just have this one entry. So everything is very straightforward and very easy to understand. But when we start adding other things into that, then our route table starts to become a bit more complicated and more populated than what you see here. Now here's the network access control list. And this is what I was talking about earlier. I probably should have waited till we got to this slide. But you can see here there's a router, right? But when you go to the portal and you're configuring your AWS networking, you don't ever see like a router, right? You have subnets that you're configuring and you have your network access control list and so on and so forth. So those are just, giving you access to their to their router using programmability. So there's an API. So if we create a subnet and apply it, so we have subnet 1 and we have subnet 2, and then to get from one subnet, within a VPC to another subnet in a VPC, we have our route table that is allowing access through the AWS router. And if we apply the NACL, the network access control list, then that's where we have to start worrying about, those rules, right? So like I said earlier, and if we come over here, like down to here, it says it's stateless. So you have to have separate rules for inbound traffic and outbound traffic. Inbound rules specify traffic sources and outbound rules specify destinations. Rules are evaluated in ascending order of priority, and the traffic is either allowed or denied based on the first match. A NACL can be associated with only one VPC. So again, you can use these, but just note that once you enable them, then you have to keep adding entries into them. So here's what we often see, and I guess it just depends on where you need to apply your security, right? So if we're trying to prevent a lot of different things from accessing a bunch of different end groups, a NACL probably does make good sense. But if it's something that's more specific, just to like an endpoint, then that's where the security groups are probably a little bit easier to deal with. And again, these are stateful. So once you establish a connection, it automatically lets the outbound, right? So I'm sorry, if you connect outbound to something established, the inbound is automatically allowed. So that's probably the biggest difference there. But they are applied. Security groups are applied to each one of the endpoints or the instances that you're spinning up in AWS. So some of the rules here is the security group rules can only allow, not deny, right? So they have you can go in and edit them, and you can add new entries to allow, right? And then you can even allow all is like one of the entries that you probably shouldn't do, other than like SSH maybe, and things like that. But even that you should restrict more. But that's how it works. It's just a bunch of allow entries, and then it's stateful, right? So you allow, and if it's not on there, it denies. And if you make a connection, regardless, so that's the inbound, right? So allowing your inbound explicitly, but anything that you connect outbound, and the default is allow all, but you can change that too, where you explicitly allow, and then it's only going to allow outbound for those things. But whatever you connect to, it'll allow it to come back in the reverse direction. So it's the security group rules are stateful. Allowing a traffic type in one direction would result in it being allowed in the reverse direction too, even if there is no rule explicitly allowing it in that reverse direction. So a little bit easier to deal with. But again, you have to deal with your security groups, across all of your endpoints. So you may have many of those and less access control lists. So kind of like a comparison there is with access lists, it's applied to the subnet. So it's just the one thing, but you might have many entries to encompass, all of the traffic that you want to block and allow. And then with security groups, it's stateful, but you have to apply them, to every one of your endpoints. Otherwise, you're allowing everything, like from the aspect of the network, and then you're denying everything by default in a security group. But you have, at some point when you start to allow things, then you're going to have to account for that connectivity, directly to devices. But you can use both of these at the same time. They're not mutually exclusive. It just depends on, like, from an operational standpoint, how you want to manage it, and again, what the use case is. If you have a lot, if you're worried about inbound traffic and what you're blocking, or if you're a server and you need to make sure that you have established connections, and security group obviously makes more sense in that example. So enough of that, just kind of confusing sometimes between the two. Now, the last part of this is a notion of load balancers, right? So load balancers, they give you the ability to connect to multiple availability zones. So if I have servers in multiple availability zones, then I can have the end user connect to the fully qualified domain name that's established and configured for a load balancer, and then through its rules, it will provide load balance connections across those endpoints that could be in multiple availability zones. So that's what we're going to see in our demo. And there's two types of load balancers that typically we're dealing with. The one that I'm going to use is an application load balancer. So that one is, in this case, it's just a web page, but it's meant to be application specific. So it's going to work directly with HTTP and HTTPS connections. With the network load balancer, it's more around the layer 4 ports. So like port 80 in that case. So with application load balancer, it's higher level. There's like kind of more that we can tune specific to an application. And then, like, I use one over the other gets into really the use case, right? So like from a performance perspective, for a lot of things, if you can use a network load balancer, it makes more sense because if there's a lot of connections and those types of things, then you would in that case, you might be better served with a network load balancer. But again, this is just the intro, so we're not going to get deep into why use one over the other. But in the next couple of sessions, then as we talk about specific use cases, then we really do need to start drilling into some of those decision points on when to use one over the other. So I think, yeah, that's kind of a transition point. So we'll start to talk about the demo, and I'll change my screen here in a second so that way I can move between some different things to show you the live demo. But before I do that, I just want to make sure that that we pause for any questions that you may have. I don't see anything in the chat room, but if you do have any questions, or if you would like to unmute yourself briefly, if any of those, these, again, it's meant to be the basic AWS networking. If you have any questions on any of that stuff, if you have any more advanced questions, just table them for the next session. But any of the stuff that we covered today so far, if you have any questions. Okay. So if everyone's ready to move on to the demo, if you could just give me a quick thumbs up so I can make sure you're still awake and I didn't put you to sleep. Cool. All right. So I'll just let them kind of float by for a second. And I'm going to take a drink of coffee here. All right. So this is our demo. And what we're going to do is we're going to use Ansible to build much of what we just talked about. I can't talk today for some reason, what we just spoke about. So from the demo, what we have here is a region. And we learned that a VPC is bound to a region. So we have a VPC, a single VPC. However, we can have multiple availability zones. So I have an A and a B availability zone. And then in my availability zone, I have one subnet that I've bound to availability zone A. And then I have another subnet that I bound to availability zone B. And both of these are public subnets. Now I could create private subnets. Maybe I have like a 2-tiered or 3-tiered application. I could do that as well. But since this is the intro, we're just going to keep it simple. So what I've done is I've created 2 web servers. Now, with AWS and Ansible, we could actually build these web servers from scratch. So I could use Ansible and I could spin up an instance with an image, an AMI image, and then once it's up, depending on what was included in that image. So if I have an image that's just like a stock image with nothing in it but like a real operating system, then I would need to use Ansible with a module. Well, there's different modules, but one of the ones that I could use is I could use the Ansible built-in Yum module to install like HTTPD, right? So that would give me a web service, and then I could, do whatever else I need to do, like firewall D configuration, make sure that I enable the service. So like Ansible built-in service for HTTP, make sure I enable that. I could do all those things programmably, automate it from Ansible, right? But I didn't do that because our focus is more on the network. So what I did is I pre-built some images, or I could have, I could have an image that I've just, pre-installed everything that I need. So you can kind of think of it along those lines. But with these right here, they're already ready to go. They're just powered off. So in our automation, we're just going to power these on. And the reason why I did that is because one of the questions that comes up often when building network infrastructure for cloud is, does it need to be immutable, or are we configuration managing components that are going to remain active, right? So more of like a permanent infrastructure versus a temporary infrastructure. So with this one, we have to take into consideration, if I have these instances that I've previously brought up and powered on, and I've installed the web service and configured it for a web page and things of that nature, those have dependencies now. So one of the things is I have to have a network interface, right? So there's this, elastic network interface, right, that remains, and it has to have a subnet. So I've already assigned the public subnet to Web 1 and public subnet 2 to Web 2. So I'm unable to delete those unless I want to decommission these instances. So that's kind of like one of the questions is if it's immutable, then I can go ahead and terminate these instances and those dependencies go away. And I could blow away this entire environment that we're building. But if I have instances or other components from the network infrastructure that need to remain, and if they're permanent, then I'm configuration managing them because I'm editing configs, I'm adding new configs to them. I'm not completely removing them, every time that I build something in the AWS environment. So maybe with like, in this case, it's a virtual machine instance. It probably does make sense to not wait to like, completely rebuild that every time. But if I'm dealing with, microservices and containers, and if I'm using like the EKS service in AWS, and I can easily, decommission pods or even decommission like an entire Kubernetes cluster, I can do all those things, and everything could really become completely disposable. But that's not always the intention. Like a lot of these environments that we're using are production that stay there. So we might have instances that are disposable, but some that may remain, permanent. So uh, one of the things about Ansible is we can actually provide automation either way. We can provision things from the ground up, or we can use more so in a configuration management capacity. And that's what we're doing here is kind of a combination. And Ansible works very well kind of in that hybrid model. Other tools, a lot of them are meant to be like, we're going to have a declarative configuration. It's immutable. We're going to blow it away. And that would be more suited for other things like a Terraform as an example. And just to point out, we actually have collections where you can use Ansible to manage Terraform. So for the things you're blowing away, if it makes more sense to use Terraform, you could do that. And then for the configuration managed components, then Ansible would take control of that, or Ansible could take, control of the entire automation as you create a workflow to kind of do immutable and config manage stuff together. And I kind of blabbed on there for a little bit, but we will see how these workflows work and how we do that in our automation platform and the ability to manage, those different scenarios. So another piece here is I talked about the two availability zones and the subnets. This is the load balancer. So it's an application load balancer. This is the internet gateway. And then this is the internet. So we can get in and out of the internet. And then inbound, we have a fully qualified domain name. It's not the Route 53 or like one of our own registered ones, since I'm just using this demo environment. I'm just using the domain name that's assigned to the load balancer. So we don't know what that is yet, right, until we build the load balancer. So once we build that, AWS will provide us that name, and we'll be able to pull that out from the playbook and use that to connect to the web server. And as we reload our page, we should load balance between Web 1 and Web 2. So that'll be our check to ensure that everything's working. All right, so having said that, that's the background. So let me go ahead and share in a different way. If you could just bear with me a second. And this time I'm going to share my window. And I'm going to bring up Ansible. Now, the only thing is, in the mode that I'm in right now, I can't see you guys. But just real quick, on my screen right now, this is the Ansible Automation platform. And let me make this a little bit bigger, a little bit easier to read. If you could give me a thumbs up if you were able to see that a second ago when I changed screens. Okay, cool. Outstanding. All right, so let me go back to here. All right, so what you see here is the Ansible Automation Platform Controller, or what we call the Automation Controller. Some of you may be familiar with Tower. So Tower is the older product, and it has evolved into the Automation Controller, which is a part of the Ansible Automation Platform. which is multiple components. So the controller is really where we manage our automation. And today we're not really going to get into like all of the aspects of the Ansible Automation platform. But if you haven't seen that before, just know there's other components in addition to this. So it's evolved into like this full platform that has a lot of capabilities, and we'll unpack more of them in other sessions. But for today, we're just going to focus here on the controller. So in the controller, you can see this was the job that I ran earlier, and this was the AWS networking cleanup. So what I had to do is I ran this earlier, so I needed to remove some of the constructs. But you can see that that I removed things like my route table and my load balancer target group that we'll talk about in my actual load balancer, and we actually power off those two virtual machines. So I did all of that so that we could build the new environment. But what I wasn't able to do, because I have those virtual machines again, is I already created those that VPC and those subnets. So I have to leave them intact. But if I were to terminate those virtual machines, those instances, then I could blow away everything. Context around our starting point. So I'm going to go over to what we call templates. Now, a template is how we can actually run what we call a job template. So we have two different types of templates. We have a job template and we have a workflow template. A job template maps to a playbook. So instead of running like a playbook from the Ansible command line, we're running a playbook from the Ansible controller. Now, if I wanted to create a workflow, then I could stitch together multiple job templates or multiple workflows. So since this is kind of the beginner part of this, we're just going to use job templates. So the first one that we're going to use is called this AWS Network Demo. And you can see here that it maps to this playbook called the network_demo.yaml. And a playbook is a YAML file. So where is this located? So Ansible is able to locate these playbooks, or the Ansible controller rather, is able to locate these playbooks through a project. So if I click in the project, you can see that this project is pointing to this Git repository in GitLab, which is this over here. So this is the network_demo.yaml. So this is the actual playbook that we're going to run. So what I'm going to do is I'm going to run this, and while it's running, we're going to return here, and I'm going to explain the playbook to you. And then by the time we do that, we'll have the output of the playbook so I can explain what happened. So let me go ahead and go back to, excuse me, to the job template. Right, so I'll click launch here. Now, what this is doing here is it's pulling down from source control those playbooks. And then now it's actually into the playbook doing stuff. So while this is running, let's talk about that playbook real quick. All right, so in this playbook, this is a YAML file. This is the one that we're building the AWS networking infrastructure using Ansible. It's local host, and what that means is when we talk to AWS from a programmability standpoint, it's a REST API. But we don't deal with REST API calls directly in our playbook. They're all abstracted into modules. And modules are really just parameters that define what we want to configure, right? And the best practice here is to variabilize those. So these are my variables right here, vars. And these variables, in this demonstration, I've co-located them in the playbook. However, these variables could be located elsewhere. That could be a part of host vars. That could be a vars file that we point to. There's several different locations where you can store variables, and they all have a precedence and a priority. And there's like 21 different locations where those could be. So we're not going to talk about all those. Just for to keep this simplified here, we're just keeping them in the playbook. But these define our variables, and the variables here use the Jinja2 variable format. So anything with these curly braces here, these are placeholders, and we are defining parameters through these variables, and then this is the configuration that's being set to those variables. So the first thing that we're doing here is we're using this Amazon.aws collection for the EC2 underscore instance module. And then this module has these parameters. So what we want to do in this case is I want the instance IDs and the state of running powers them on. So Web 1 and Web 2 are defined right here. These are their instance IDs. And those are assigned when you create that virtual machine. So we're turning them on. And then I'm creating a VPC. So this VPC already exists because I've already created these virtual machines previously. So what's going to happen here is each one of these modules has a default state of present. And if you want to delete them, it's absent. So you can change the state. But because present is the default, I don't have to explicitly call it out here in these modules, or at least not some of these modules. Some of them do require you to do that. So what this says is if this VPC doesn't exist that we're creating, then it will create it. But if it does exist, it's just going to move into the next task. But we still want to keep that here because we want to communicate with AWS so that we can pull in the IDs. So that's kind of the trick here when programming AWS is we need to find out what the AWS IDs are because we have dependencies. So when we create a VPC, we have a dependency first, like we have to create a CIDR block. So that's something that we have to do. We have to tell it what region that it's running in. And then this is just if we're going to validate certs or not. In this case, we have to. But we could turn that off, like if it's some type of other lab environment that doesn't have a certificate. So these are parameters that we're setting at the VPC level. Now, one of the things about the VPC is we create subnets. So the subnet, before we can build it, we have to tell it what VPC. So in order for us to get that ID, what we do is even when we're running it and it's idempotent, right? So it's not going to recreate it, but it will give us all the information that was already established. So it's going to tell us here that we register VPC. So this is just an arbitrary name. We're registering all the structured data from communicating with this module. So in order to parse to that, this is called VPC. I can have VPC and either use dotted decimal or I can use the open braces with quotes. But this is what's inside that structured data. So if I were to do a debug command, we could print it on the screen, and we would see that to parse to it. Then as we parse through that data structure in that dictionary, the next level was VPC and then the ID, right? So that gives us the ID that we need so that we can associate public subnet to that VPC. And then we want to put it in an availability zone. So availability zone 1 is defined up here. It's US East 2A. And then in the diagram, we had a B, an A and a B. So when we create that second public subnet, we're sending it to the second availability zone. So we're just defining these variables here and then applying them when we run through these parameters. So each one of these we register because we may need that structured data to apply it to one of the subsequent tasks that we have underneath those tasks. Now, this is kind of how you look at it from like a playbook perspective. But when we create the workflows, we can also use fat caching, where this is all going into memory. We can have that stored into storage in the AAP, so that way we can share information not just within a playbook, but between playbooks or between job templates and also between workflows. And that creates the ability to do artifacts, right? So that we can move data around so we don't have to keep, querying information again. We have that, and then we can delete it when we're done with it. So most of the information that we need, when anything we're talking about AWS, are all these different IDs that we need to establish a configuration that has a dependency on an ID from something else. So as we move down here, the next thing is I have to associate the subnet to an internet gateway. Right. So again, just to save time, there's more IDs. But what's happening here is we're associating that subnet, and we're also creating the entries for the route table. And we're tagging the route table because I want to be able to delete the route table after we're done with it. So that gives it like a unique name that we can go back and remove it. So we work our way down. The next thing is security group. And here we're allowing port 80, right? Because we're going to have a web service. And we're also allowing port 22 So we can SSH into those two web servers if we need to. So if for some reason I need to change the web page or whatever, I can have access to that. But port 80 is where we actually have access to the web page. And then we're creating a load balancer target group. So that is opening up port 80 and it's connecting to web 1 and web 2 because we have those two instances, those two VMs that are web servers. By default, the ID is using the instance ID, but you could change that to an IP address. So especially if you're going to blow away these virtual machine instances, but you're going to use like static IP addresses or give them the same IP address every time, then regardless what the instance ID is, then you could keep those targets in there to make it easier to map them back, to the load balancer through this target group. And then the load balancer itself has to connect to the network, right? So it's connecting to both of those availability zones, A and B, through the public subnet, and there's two of them, the public and the public one. So we have these two, different subnets, and we know what those are because we register that up here when we created them, right? So it goes into memory here, and then we can pull that out later. And then what we need ultimately is we want to culminate on what that address is so that we can connect to the actual server. So let me go ahead and go back here, right? And let me refresh so we can see what happened. All right, so here we didn't create a new VPC because it was already there, and we have that, that present is like a merge. So it won't rebuild it, but it does show me like all the information, right? So all the IDs and stuff is a part of that. So you can double click in here to get access to that structured data. And then we didn't create the subnets again because those are connected to those two virtual machines. So we leave them alone. The same thing, the internet gateway, because we needed that to be able to connect to the VPC back to those instances. But the stuff that I could remove is the link from the subnet to the internet gateway. I left the security group because that's applied to the endpoint. So we left that alone, but we can see, information about it, that it's allowing port 80. And also if I were to scroll down, port 22 as well. And then we have the target group. I removed that because that has no bearing on the endpoints, right? So we remove that. We also provide a target because that gives us the ability to go back later, and we can remove like the route table and things like that. So we're at a point now where we have a load balancer. Here's the load balancer. And actually, I put it on the screen anyway, but in here at the bottom of that is this. This is what we really want here is the address. So I can copy this out of here, and we'll make a new tab up here. And just to be careful, we're doing port 80, so I should put this in just in case. All right, so the first one that came up was web 2, but it's load balanced, right? So I have a web 2 and a web 1. So let me make that's hard to see. All right, so we're on web 2, web 1. All right, so we have everything up and running and connecting to it. So if we're done with this, so say it's a temporary web service, then the other thing that we could do is I go back to my templates and I have the cleanup that I showed you like earlier. And we can let this thing run and it'll remove the load balancer, the target group, the route table, the mapping to the networks, but it keeps the actual subnets because they're already connected to those VMs. And if I were to terminate those VMs, then we could actually remove that stuff as well. So while this is running, which probably takes a couple minutes here, has to stop the VMs and so on, I'm going to pause for any questions that you may have because we're almost out of time here. So I'll skip over to here real quick and just to check to see what we got going on here. Yeah, so when you look at the So this question here about the JSON, when you look at the output, it's in JSON, but when we configure everything in the playbooks, it's in YAML. So that's just the output that we're looking at. But we can convert that output into YAML too if we wanted to, but that's just the default from the screen output, from the controller. So that's what you saw there. That's how you see task results on the automation control, but actually it's defined. Oh yeah, so pretty much. Thank you, Jordy. You said the same thing. So what is the advantage of using Ansible Playbook as opposed to CloudFormation? Yeah, so the difference is, so like with CloudFormation, you're building templates and you're creating, all your constructs in AWS, which is fine if you're working with, just, regular AWS types of components, right? So this was like a beginning type of thing. So the answer is yes, you could clearly easily do everything we just did with CloudFormation templates. But where it starts to get trickier is when you start to do other things. So I mentioned we're going to start doing more network types of things where we connect, like instead of using the AWS router, using like a Cisco Catalyst 8000 or using like a Palo Alto firewall, instead of just relying on security groups and things like that. When we start to do those things, we may want to make those particular virtual appliances, we want to automate configuring them as well. So we have collections and modules across a large ecosystem where it's very easy to automate those things, whether they're on-prem or in AWS cloud. So the more you add complexity into the network, the more likely you're going to run into a brick wall trying to do everything, with CloudFormation templates. And you maybe like have all sorts of workarounds or whatever, but when you get into like performance and how you want to manage things like that, then that's where the platform may offer, a method that's a lot easier to kind of flattens that all out. Would it be possible to use Ansible templates for multi-cloud purposes, or would we need to create multiple templates for AWS, Google, and other services? Yeah, so the way that works, it's sort of maturing. So if you look at what we're doing with the traditional network vendors, if you configure Cisco, Juniper, Arista, they each have collections with modules. And more specifically, currently, people tend to use more the network resource modules. They're easier to configure, especially since it deals more with structured data and things like that. So you can use each one of those and build a playbook and have conditionals to say, this module is for Cisco, this one's Juniper, this one's Arista. But moving forward, what we've done more recently is we've created validated content for the network. And in validated content, it's like an advanced role that takes care of all the multi-vendor aspects. So I can create an inventory and have like multiple vendors. And I could say, build this thing. And in my inventory, it's gone across groups that are these different vendors. And Ansible will handle like all the nuances of the modules. It abstracts all that. And what we'll see is a very simplified playbook that we put together, and the role of the validated role handles all that stuff for us. So to the question about AWS, Google, and Azure, right now they have collections and modules for us. So we can build like all of their network constructs with Ansible, right? So we could do a multi-cloud using like each one of their individual collections of modules and build the things like the express route versus direct connect versus the way they do VPNs and things like that. But moving forward, the idea with those as well is to start to move more into like a multi-cloud, sort of a multi-vendor, multi-cloud kind of thing where we start to abstract more of that away. So if you're building something like a VPC and they all have a notion of that, then you can build it, a standard way instead of having to use 3 different modules. But even with using 3 different modules, it's still pretty straightforward. So you don't have to use CloudFormation and something else and whatever with Google, to build like a multi-cloud environment. You could use Ansible and Ansible Automation platform, and the controller would manage your playbooks, and you would just point them, to each one of the clouds and bring up your network peering, and you would be good to go in that regard. But that was a great question, Nicholas, because that's kind of the direction where a lot of these things are going, and the reason, a very good, value reason for using Ansible in that context. So one last thing, let me jump back here and refresh this output. And you can see we deleted the route tables and just scrolling up the load balancer target, the application load balancer. We stopped the instances. So we just kind of rolled it back. And obviously because of that, if I go into here, we can no longer access this domain name anymore because that load balancer has been completely, decommissioned and it no longer exists. So with that, and due to time, I'm going to go ahead and shut this one down. But if you like this session, please return February 22nd, and we'll get into some more advanced types of things with peering our VPCs and doing a little bit more in terms of networking and complexity. I hope you enjoyed it, and I'll talk to you next time. Take care.